Hello, we are a team of 5 researchers from Institut des Géosciences de l'Environnement in Grenoble, and we are here in Kangerlussuaq, Greenland, to study the dynamics of Innsbruck-Sermia Glacier on the ice cap. In Grenoble, our institute works on glaciers in many places around the world. In the Alps, the Himalayas, the Andes, Antarctica, and Greenland. This year, we carried out an important project on the Greenland ice sheet. The goal was to better understand how the Innsbruck-Sermia Glacier behaves by using geophysical methods. The first field mission took place in July with a team of 9 scientists. One of their main tasks was to drill through 700 meters of ice to reach the ground underneath the glacier. This way, we can study the rocks and water flowing at the base of the glacier. Inside the boreholes, they installed sensors to measure temperature, pressure, and ice deformation. They also placed seismometers which record vibration inside the ice. These instruments help us detect when crevasses open or when meltwater flows at the surface during summer. Now, in October, our team is returning to replace the batteries and collect the data recorded during the past few months. We will spend about 3 weeks in Greenland waiting for a good weather window to reach the glacier. This is not an easy task. Here, in October, winter is slowly starting and the days are getting shorter. To prepare for such an expedition, we use a scientific base in Kangerlussuaq called the Kangerlussuaq International Science Support. It's where we organize all our equipment before going onto the ice. About 4 months before the mission, we send all our instruments by ship from Grenoble to Kangerlussuaq. Once they arrive, we sort everything and pack the gear and instruments that will be flown to the glacier by helicopter. When everything is ready, the helicopter drops us and our gear at our ice camp, about 30 kilometers from Kangerlussuaq. Our camp includes sleeping tents, a scientific tent for instruments and work, and a mess tent, where we cook, eat, and talk about our plans for the day. The tents must be very strong to resist high winds and freezing temperatures. Indeed, in October, it can reach minus 13 degrees Celsius, with winds of 70 to 100 km per hour. Working in these conditions is tough. We can't keep our gloves off for too long, and we must be careful to avoid frostbite. Once we are all settled, we start our scientific work.
The most important task is to recover the data obtained from the optic fibers installed in the 4 boreholes in July. These optic fibers are connected to 3 different devices that give us strain rates, temperature, and deformation of the ice. We must then bring back these instruments to France. At each borehole, we also pick up the seismic data, pressure data, and GNSS position evolutions since July.
The initial goal included to replace the batteries and loggers of the node array, so that the sensor continues their acquisition during winter and spring 2026. But the strong wind and drift created snow accumulation and thus makes it difficult to find the nodes. Even once they are found, they can be stuck in the ice and therefore hard to pick up. Given the bad weather, it becomes unrealistic to swap 195 nodes, and we must shorten our mission on the glacier. That's why we have to give up after 13 nodes. But work does not stop here. Once we are back in Kangerlussuaq, we have to pack everything and to start post-processing the data while waiting for a plane to finally bring us back home.